Worksheet 10A, Transverse Shear Stress. For this problem, they give us the section of the W14 by 82. Basically, that is the Y flange shape. Determine the first moment of outward areas, that is Q, the first introduced in today's class, the first introduction in today's class. And then at the top, where we need to find out Q, at the top and the bottom fibers. So basically top and bottom fiber, the point that you call. So let's talk here. The point we looking at is point A. At the top and bottom of the web flange intersection, so that is the point they are looking at, and that you can see this is symmetrical, so we just only put the top, the bottom should be the same. This cross section, Y flange section, symmetrical in X direction and Y direction, and it also at the neutral axis of the cross section shown. This, like I say, it symmetrical in X and Y. The neutral axis go through the centroid, and the centroid of cross section here, you don't have to spend time to find out because it's already in the middle there. At this cross section is symmetrical in both X-axis and Y-axis, and at the beam you set up, the neutral axis will go through the centroid and parallel to X or Y axis. At the beam, it will be parallel to the X as we just show, and that is the neutral axis we are talking about. So with that, we want to find out what is the Q at A, at B, and then neutral axis, so we call that is C. So let's do one at a time. So let's find out the top and the bottom fiber. So the first, we want to find out what is the top and bottom. So basically point A that we want to. So here, that one, these two top fiber, bottom fiber, and it, like I said, it's symmetrical. It should be the same. So the equation that we have, this is standard shape. So we can have the equation for the first moment of outward area Q, in this case equal to sum of Y bar over A apostrophes. That's what we learned. And you can see the A apostrophe, by definition in our class, the A apostrophe, the outward area from the point of interest to outer edge. So with that definition here, you see the point A is the point that in interest, and outer edge is also A, because that is the point already at the top fiber. So the areas is equal to 0. For this case, area equal to 0 from the point of interest, point A, to the outermost fiber, also A. So the area is 0. So from that, we can have the Q for the top and bottom. So at point A, you can see that here is 0. And if you want the unit, you see A apostrophe, the area, so in square, Y bar is in, so that in cube for the Q. So that is the unit for Q, inch cube or millimeter cube or meter cube. That is the first portion. And also now the question asks the top and bottom of web flange intersection. So the point B that we want to find out. So let's talk about the next point, which is the web and flange intersection. So that is point B we are talking about. Point B to be talking about. And the equation the same. Q equal to sum of all y bar times a apostrophe, nothing else, as you can see there. And now we go ahead to find out Q and with y bar and with a apostrophe. So a apostrophe, that by definition is the outward areas measured from the point of interest to the outermost fiber. So at point B, as you can see here, the area a apostrophe is equal from the point of interest, that is point B. So let me draw it here, and I will erase later on. So that point B to the outermost fiber, so that the area here is the area we are looking at for this a apostrophe. So that one is equal to the, ignore the fillet, so you can see that the area in that case is equal to 10.14 inches. Just consider that a rectangle times the thickness of the flange, 0.855 inch. So from that one, we have the a apostrophe equal to 8.67 inch square. So from the point of interest to the outermost fiber, so as you can see, point B to the outermost fiber, in this case the top, so it on way from here to the one that we are talking about. Okay, so with that we already find out the a, and now y bar. Talk about y bar equal to what? Y bar by definition is distance from the neutral axis to the centroid of the outward areas. Distance from the neutral axis, where the neutral axis there, to the centroid of the outward area. So let me call that is neutral axis to the centroid of that outward area. So that here, so it will be go through that point. Let's put in color there. So y bar for this problem, right? And for this, what is y bar for that one? And you can see it equal to what? To the half of the height of the beam. So it equal to 14.31 divided by 2, that half of the beam, subtract half of the thickness, then you get y bar, right? So we have it here, minus the thickness of the flange shapes, 0.855 divided by 2, half, because the centroid, the black point here, as you can see, go to the middle of that rectangular shape of the flange. So it will be half of the width of the beam, 14.31 inches. That is from the neutral axis to point A. Subtract the thickness, half of the thickness, which is from point A to the centroid. So you will get y bar in that equation. And that here you have Q y bar from that calculation, 6.73 inches. So we have y bar and Q, then we y bar and a apostrophe, so we can have Q in this problem, wet flange intersection point B equal to only one shape, so you have a y bar 6.73 times a apostrophe 8.67. So you have Q equal to 58.3 inch sweep. And that the same at the point intersection at the bottom. It should be the same at this point too, right? Because that's symmetrical. So that's what we have. So let me erase this y bar here for that and move on to the next one, how to determine the y bar for. The next is what is the neutral axis, right? The first moment of outward area at the neutral axis of the cross section. So that is point C we are talking about. So where here we have the neutral, we have space there, neutral axis, and that is point C represent that we have it in the cross section. So again, we also have the equation Q sum upon the y bar A apostrophe. And in this case, you have two shapes from neutral axis to the outermost fiber, So from the neutral axis. So you have two shapes. The shape one, we already saw that is the flange. And the other shape, let me put in different color. Let's put that in green here. Which cross green that you have. So you have two from the neutral axis to the top of the outermost fiber. We have green, and then we also have the black for the flange, right? Flange shape, and then half of the web. So with that, we have here, because that measure the A is from the outward area, from the point of interest. Our point of interest in this case, this point C, to outermost fiber, either go top or bottom in this case because they are symmetrical. Okay, so we have two areas for that. So the first one, as you can see, for the first is the flange. Let's talk about flange. What do we have? The A still the same on the other side that we do it already. We already do, but I just read right here, and you can see equal to 10.14 times 0.855. So you have it 8.67 inch cube, or in square area, in square. And then we have y bar, we already done on the other side. We just rewrite 6.73 inches. That is flange. Now the web, which is the blue shape that we have it in the cross section, blue shape. So web, half of the web, because that from the neutral axis. So A apostrophe outward area for that, because we can break down sum of all the two standard shape, right? The rectangular shape for the flange and the web, half of the web, because that measure from neutral axis. So how can we find out the web? It equal to this length times the thickness, and you can see there. So that length equal to what? Write down. It equal to half of the height of the beam. So 14.31 divided by 2 minus the thickness of the flange minus 0.855, and you can see thickness of the flange. So that is this distance. It's distance there. And then the thickness of the web we already have, which is 0.510. So from that we can have A for the web, A apostrophe 3.21 inch square. And then we have y bar. How to find out y bar? By definition, y bar is the distance from the neutral axis to the centroid of the outward areas. So for this case, we deal with this. So the that centroid, it will be here for the web, right? So the question now is, let me erase this so that don't make confused. So the distance that y bar here is from this. How can I find out that distance? Okay, so that is the y bar that we want to find out for the web. So it equal to, as you can see, the half of BC, right? Half of BC. That is the web, the blue one. So half of BC. So here, how to determine the half of BC? Basically, it equal to half of BC. BC equal to 14.31 divided by 2. That is half of the height of the beam minus the thickness of the flange that you have BC divided by 2. You will have y bar for yes. And that y bar equal to 3.15 inch. So from that we have A apostrophe and A bar for each flange and web. So go ahead to find out the Q for first moment of outward areas at the neutral axis. That's the point of interest. So Q, as you can see, equal to sum of A bar, A apostrophe. So it equal to A67, 6.73, which is point in there, right? Point in there. That you have that here. We already find out. And then we also plus 3.15 time. Let's put in order there. 6.73 time areas 8.67, and then we have 3.15 y bar for the web time 3.21. So from that we can have Q equal to 68.5 inch cube, and that is the answer for the first moment of outward areas at the neutral axis. So basically, as you observe, for the neutral axis, you only need to find out the Q for the web, add with the Q for the web flange intersection 58.3, you will get 68.5. So that bottom line, you will see always the first moment of outward area at the top or bottom of very outermost fiber is always 0, and then the web flange you have Q, and it also neutral axis, that's the biggest. So bottom line, Q you get the biggest in neutral axis and smallest equal 0 at the outermost fiber, and that done for the the first moment of outward area. Very important, because that then go to the next, we will apply that to find out the distribution of the shear stress, the transverse shear stress.